For centuries, figuring out the fundamental laws of physics, well, that was a uniquely human thing. It took a Newton, an Einstein, a human genius. But what if the next great breakthrough, the next fundamental law of the universe, is discovered by something that isn't human at all? That's what we're going to dive into today, how artificial intelligence is on the verge of becoming our partner in rewriting the rules of reality. So you might be asking, why do we even need AI's help? Well, it really starts with a pretty humbling fact about how little we actually know. Just look at this. Everything we understand, all the stars, the galaxies, you, me, everything we can see, that makes up just 5% of the universe. The other 95%? It's something called dark matter and dark energy. And honestly, we don't really have a clue what it is. And it's not just that big mystery. Our best theories are hitting some serious walls. We've got these two amazing rule books for the universe, general relativity for the big stuff, like planets, and quantum mechanics for the tiny atomic world. The problem? They just don't play well together. They actually contradict each other. And on top of that, our telescopes are spotting all these weird anomalies in the cosmos that our models just can't explain. It really feels like we're not just missing a few pieces of the puzzle. It feels like we might be using the wrong puzzle box entirely. So where do we go from here? This is where a radical new idea comes in. We've got to stop thinking of AI as just a faster calculator or a bigger spreadsheet. The real game changer is seeing it as something else entirely, a new way to think about the universe. Okay, so how does an AI actually think about physics? Well, one of the coolest techniques is something called symbolic regression. Now get this. Instead of a scientist telling the AI what kind of pattern to look for, you just give the AI the raw data, say the positions of a planet over time. And the AI's job is to work backward and figure out the simplest, most elegant mathematical equation that explains that motion. It's not just finding a trend, it's trying to find the actual physical law. And the process itself is just so elegant. You start with the raw data, all the messy observations from a telescope or a particle collider. The AI then just dives into this ocean of information, looking for hidden connections, patterns that a human brain might never, ever see. And then, out of all that complexity, a potential physical law just emerges. A clean, simple equation, like something right out of a physics textbook. And listen, this isn't just a cool theory. It's already been done. Researchers built a system they called AI Feynman, and they fed it data from basic physics experiments, but they gave it zero context. And the AI, all on its own, rediscovered some of the most fundamental laws of mechanics. The kinds of things that took geniuses like Newton centuries to figure out. So that, of course, leads to the big, thrilling question. If AI is smart enough to find the laws we already know, what's going to happen when we point it at the data we don't understand? What new physics is just sitting there waiting to be found in all the data pouring out of the Large Hadron Collider or in signals from the most distant galaxies? Now, the reason AI might be able to pull this off is because of how it thinks. Our human intuition is amazing, but let's be honest, it's limited. We evolved to think in 3 dimensions. We like things to be simple, symmetrical, linear. AI has none of that baggage. It can navigate these incredibly complex mathematical spaces with hundreds of dimensions, finding emergent rules without any of our built-in human biases. And its role could go way beyond just spitting out an equation. Imagine having an AI as a genuine partner in the lab. It could optimize our experiments in real time, telling us, hey, point the telescope over here next. It might even identify brand new physical concepts, ideas as revolutionary as energy or momentum were in their day. Heck, it might finally be the thing that helps us unify all the different fields of physics, finding connections that have been right under our noses the whole time. Okay, this all sounds pretty incredible, but it also leads us to a really deep, almost philosophical problem. Let's say an AI gives us a new law of the universe. It works perfectly, it predicts everything, but we have no idea how the AI came up with it or why it works. Is that still knowledge? This is the challenge that people are starting to call black box physics. It's this very real possibility that machines could develop an understanding of the universe that is, quite literally, beyond human comprehension. The math works, the predictions are spot on, but the reasoning, it's locked away inside a machine in a way our brains just can't access. Here's probably the best way to think about it. AI could be for us what Galileo's telescope was for astronomy. I mean, the telescope didn't just let us see a little bit farther. It completely transformed our perception of reality and our place in it. AI might not just augment our intelligence. It might totally transform what it even means to understand a physical law. So just chew on this for a second. Every scientific theory we've ever had has been, in some way, a reflection of the human mind. Our love for elegance, for symmetry, for causes we can understand. A theory generated by an AI would have none of that. It could be correct, it could be perfect, and it could be fundamentally alien. And that leaves us with this final, really mind-bending question. As we stand here on the edge of this new frontier, we have to wonder, what secrets is a non-human intelligence going to show us? Not just about the universe out there, but about the limits of our own understanding.